I suppose we could say this is, it's hard to let go of these things. You should just let it go. But let's try one more thing, then we're out of here. So the sixth power is 1 minus the square cubed, right? So yeah, actually this could be fruitful, right? So 1 minus cosine squared is sine squared, right? So if I raise that to the third power, yeah, actually this, right, there's 3. See the 3 over there? So we had 3 here, but yeah, not in the factorization. So this is plus then 1 minus sine squared beta cubed. And what happens when I expand this? Well, 1, 3, 3, 1, right? Again, Pythagoras is Pascal's triangle. So 1 times whatever minus 3 cosine squared beta plus 3 cosine to the 4th beta minus cosine to the 6th beta. Oh. What happened there? Is that correct in the first place? Yeah, notice that the powers of cosine squared are increasing. So cosine squared to the 0, cosine squared to the 1, cosine squared squared, cosine squared cubed, and the coefficients are 1, -3, 3, -1 because it's a negative. Okay, so the same thing here. I'm not so happy about this now, but this is 3 sine squared beta plus 3 sine to the 4th beta minus sine to the 6th beta. Oh. That's funny because now we got our cosine and our sine back, right? So we can say, look, sine to the 6th beta plus cosine to the 6th beta is equal to that. And we can add sine to the 6th and cosine to the 6th to both sides. So we'll have twice sine to the 6th beta plus cosine. I'm totally off the reservation now because I'm not, right, I'm working with an equation, but I'm going to get my cosine to the 6th, cosine to the 6th back, right? So this is 1 plus 1 is 2, right? That's the 1 plus 1. I've taken care of these guys, so that leaves these other 4 terms, right? What am I going to do with those? Well, I can factor out, yeah, see that? You can factor out, huh? So minus 3 times cosine squared beta plus sine squared beta. That takes care of this one and that one. Is that agreeable? Ah, it's true, isn't it? Okay, so then I'll use these, which I can factor out at 3 again. Cosine to the 4th beta plus sine to the 4th beta. We need to take a break here, so we better wrap this up or let it go. So what do you got here?
One.
Pay dirt.
Pay dirt.
So this is 1, right? So this is 2 minus 3 is -1. Oh, -1, that's weird. And then we got 4th power. We don't have any 4th, whoa. Yeah. Oh. Well. Yeah. So this is plus 3 cosine to the 4th. I don't know what to do with this sum of 4th powers. But we do have sine to the 4th over there, so I suppose we could say it's the square of the square and kind of try to make these things match up. So the problem, this is twice the left side, right? So this thing is twice the left side, so I'd have to divide it by 2 to get the left side.
Hmm.
Yeah. And, let's see, here we have all signs, right? So we could write this in terms of all signs. So this would be -1 plus 3 times 1 minus sine squared beta squared plus sine to the 4th beta, because that's already sine. So this is -1 plus 3 times 1 minus twice sine squared beta plus sine to the 4th beta plus sine to the 4th beta. Like that one, right? So I just expanded this square with these 3 terms, right? And what does that buy me? Well, -1 plus 3 is 2. That's good, actually. I've got a 2, right? Because there's a 2 over here.
Mhm.
And then I've got
Two.
-6 times this, right?
Yes.
-6 times sine squared beta. Then I've got 3 sine to the 4th plus sine to the 4th, that's 4. That's good. So I got all even coefficients. And that's twice sine. So I can put this together, right? So this equals that, and that tells me that sine to the 6th beta plus cosine to the 6th beta is going to be half of this, which is 1 minus 3 sine squared beta plus 2 sine to the 4th beta. Et voila. Boom. So that's it. We proved it. Let's take a break.